Hello, welcome back, algebra students. I named this video the basics of the quadratic formula. So in retrospect, I probably should have started with this lesson last week, but live and you learn. You guys were thrown into the fire and you did really well. I think this week will be a little easier for you. So the basics of the quadratic formula, to explain that, I'm going to start with a linear equation. So I've got two of them here. I have y equals x and I have y equals 2/3 x plus 1, and I graphed both of them for you. Now I'm going to walk you through filling out the xy table. And all that is, xy table are going to be a bunch of ordered pairs, a bunch of points that are on that line. And I'm going to use for my x values -3, 0, and 3, and then plug those into the equations to see what the y value would equal for those given x values. So -3, 0, and 3 in both of these charts or tables. So there you go. So in the first one, x equals y. Whatever I put in for x, I don't have to do any math. That's what y equals. If I replace the x with a -3, it'll say y equals -3. So if x is -3, y is -3, and that's the same for every number. So my table looks like this. -3, -3 is 1 point on this line. So if I put in my little tick marks on my graph, -3, -3 is right down there. And then 0, 0, well, that's the origin. And then 3, 3 is in the first quadrant. So those are my 3 points that I just plotted using my table. And you can see they're all on a line. You connect those points, it's a straight line. You can do the same thing in the next problem. The math is a little bit more complicated, but I picked -3, 0, and 3 on purpose because when you plug those numbers in for x, they cancel out with the denominator. So if I plug a -3 in for x, I'm going to have 2/3 times -3. That's -6/3, 2 times -3. And -6 divided by 3 is -2. So my value would look like this. I'll show you the substitution. 2/3 times -3 plus 1, that gives me -2 plus 1, which is -1. So here's me showing you the work. Instead of 2/3 times x, it's 2/3 times -3 plus 1. 2/3 times -3 is -2. The 3's are going to cancel out, because remember, when you multiply a fraction times a whole number, it's over 1. So it's 2 times -3 and 3 times 1. That'd be -6/3, which reduces to -2. Instead of doing that work, you can just cancel them, make this a 1 and this a -1, and you'll have 2 times -1 over 1 times 1. Anything over 1 is just itself, so it's 2 times -1, which is -2, and -2 plus 1 is -1. So the point -3, -1 is going to be on the line, and I added that in. That's this point right there. And then if you plug in a 0, that's the easy one. Anything times 0 is 0, so this would just be 0 plus 1, which is 1. So the point 0, 1 is on the graph, and that is the y-intercept. And that's why this number that's by itself is always the y-intercept, because when you plug in 0 for x, it doesn't matter what the slope is. Slope times 0 is 0. So you're just left with the constant, which is the y-intercept, b, also known as b, y equals mx plus b. And then you plug in a 3, and it'd be just like this. It would cancel out, but that would be a +1. So you'd have +2 plus 1, which would be +3. So the point 3, 3 is right there. Those are your points on the line. It forms a straight line. Why am I going through this exercise with you? Because I'm going to do the same thing now with a quadratic equation or quadratic function. But before I do that, I want you to notice that the way you could tell right off the bat just by looking at the equation if it's linear is if x is to the first power. That means basically it's just an x by itself. There is no exponent. Anything to the first power, we don't even write 1 for the exponent. We just leave it off. So both these equations, y equals x and y equals 2/3 x plus 1, x is just x. It's not x squared or x third or x to the fourth. It's just x to the first power. That's a linear equation. What makes a function a quadratic and gives you a parabola when you graph it is when you do x squared. Now, if you have an x squared in your equation, regardless of whether you have another term with an x in it or not, as long as one of the terms is x squared, it's going to be a parabola. It's going to be a quadratic function. So how would we graph this? We would substitute in numbers for x, just like we did with the linear equation, and I'll use the same numbers. I'll use -3. Well, I'm going to use a couple more. I'll do all the numbers from -3 to +3. So -3, -2, -1, 0, 1, 2, and 3. So in this one, I'm going to substitute in 7 numbers for you guys. So let's start with -3. Y equals -3 squared instead of x squared. Well, a negative times a negative makes a positive, so that's going to be +9. All right, and that pattern is going to hold. All we're going to do is square these numbers. So you substitute in a -2 for x squared. And negative times a negative is a positive. 2 squared is 4. So we get 4 for that. For -1, we get 1. For 0, 0. And then the pattern is the same for the positive numbers as it was for the negative numbers. So -3 and +3, when you square those, both give you +9. The 2's give you 4. The 1's give you 1. And the 0 gives you 0. So if you try and plot these points on a graph, you're no longer going to have a straight line. You're going to have a parabola that's going to look something like this. 0, 0 is right there, and then it's symmetrical around the y-axis. -1, 1 would be right about there. 1, 1 would be somewhere over in here. 2, 4 would be up in this region. 3, 9, now you're starting to go up real fast. 4 would be 16, way up off the slate here. So it's symmetrical. You can see by looking at the numbers, you can see by the graph that a parabola is always symmetrical. Now, it's not always symmetrical around the y-axis. You can move a parabola to the right, you can move a parabola to the left, and that's where the bx comes in. So right now, all we had was ax squared in that example. That example I just showed you was ax squared, where a was equal to 1. If you substitute in a 1 for a, you get y equals 1 times x squared. We don't need the 1 because 1 times anything is itself. So it's just y equals x squared. B would be 0 and c would be 0. There were no b or c terms in that example. But if we put a b term in there, say we have plus bx, so we add in our bx. If b is a negative number, then the graph is going to shift to the right. If b is a positive number, the graph is going to shift to the left. Now, Desmos.com, the graphing calculator app, is really good for illustrating this. If you go to that website and you click on the little 3 lines in the top left-hand corner, a menu will drop down, and you scroll down to Parabola, click on Parabola, it'll open up a graph where it gives you slide bars for A, B, and C, and you can change the values of A, and as you're changing it, the parabola is going to change. So you can see what the different values of A do to the graph. You can see what the different values of B do, and you'll see what I'm talking about here. If you make B negative, your graph is going to shift to the right. If you make B positive, your graph is going to shift to the left. And then C is your y-intercept. So if you make C positive, it's going to move the graph up. If you make C negative, it's going to move the graph down. Now, what A does is what you really need to know, at least for the homework tonight. And what A does is, if it's a positive number, your parabola looks like this. It's what's called opening up. It means that the vertex, the bottom of the parabola, is a minimum, and the graph opens up. So this is called open up. All right, if A is negative, if you have a negative A, then it opens down. And when it opens down, it just flips your parabola upside down. So it would look like this. A negative A means it opens down. So let me show you what that looks like. If we had y equals negative x squared. Now, instead of positive x squared, we could still do our xy table. I'll just do 2 to 2 this time. -2, -1, 0, 1, and 2, just so it goes a little bit quicker. And if we substitute those numbers in, this is the only tricky part. When you substitute those numbers in, it's better if you think of the equation as this: y equals the negative of x squared. So put x squared in parentheses, and then when you substitute in a negative 2 for x squared, whatever answer you get, you make that negative. So as we showed in the last problem, a negative times a negative is a positive, so you're going to get 4 when you substitute in negative 2 for x squared, because 2 times 2 is 4, negative times a negative is positive. But in this case, it's the negative of x squared, so it's actually negative 4. So you get negative 4. So all these numbers now are going to be negative instead of positive like they were in the last one. So your chart would look something like that. And then when you go to graph it, negative 2 would be down at negative 4. Negative 1 is down at negative 1, 0, 1, negative 1, and 2, negative 4. Now you can see that your parabola is flipped upside down. So that's part of the homework tonight, is just state whether the parabola opens up or it opens down. All right, and then the second part of it is to say, what is the axis of symmetry? Which sounds complicated, but it's really not. Axis of symmetry is just, where is the line that goes straight up and down that splits the parabola in half, right? Symmetrical means that one side is exactly the same as the other side. If you could fold this as a piece of paper, the two sides would match up exactly. So we want to know, what is the equation of the line that splits the parabola in half? Well, in all these examples so far, it's been the y-axis that has split these graphs in half, and the equation for the y-axis is x equals 0. X equals 0 is another way of saying the y-axis, because it's a line that goes straight up and down and crosses the x-axis at 0. So if your parabola looked like this, say it looked like that, it's shifted over to the right 2 spaces. That means the axis of symmetry splits the parabola in half, and it's crossing the x-axis at 2. So then your equation for the axis of symmetry would be x equals 2. All right, well, how are you going to find this if they don't give you the graph, if they just give you the equation? So say they give you an equation that looks like this: y equals x squared plus 4x plus 5. Say that's your equation. Y equals x squared plus 4x plus 5. It's hard to tell just by looking at it what that graph looks like. So how are you going to be able to tell what the axis of symmetry is? Well, there's an equation for it. It's x equals, it's always going to be x equals some number. And to get that number, you use this formula: negative b over 2a. Negative b over 2a. All right, so if you think back to the quadratic formula that we used last week, it was negative b plus or minus that whole square root thing over 2a. So that's where the negative b over 2a comes from in the quadratic formula, is the axis of symmetry. So in this case, b is 4 and a is 1. So you'd have negative 4, or I should say the negative of b, the negative of 4 over 2 times 1. And the negative of a positive 4 is negative 4, so you'd have negative 4 over 2, and negative 4 over 2 is negative 2. So the axis of symmetry in this problem is x equals negative 2. So your parabola, the graph would be opened up because a is positive 1, so it's going to open up, and the axis of symmetry is negative 2, so you're going to be to the left 2 spaces. So it's going to look something like this. Now, we don't know for sure if that parabola is slid up or slid down, but we don't have to know that for the homework tonight. You don't even have to graph it. I'm just kind of showing you that x equals negative 2 means that your parabola is moved to the left 2 spaces. We'll get into later in the week how far up or down it got shifted. But that's the 2 answers that you need tonight. You got to look at A and say, is it negative or positive? Does it open up or down? And then you use negative b over 2a to see what the axis of symmetry is. Where is the middle of the parabola? Where is that line that if you folded the parabola on that line, the 2 sides would match up exactly? And that's how you do it, negative b over 2a. So that's your basics of the quadratic formula, of the quadratic function, of the parabola. So hopefully, if you were having a hard time last week, this takes it back a step, and this gives you a little better idea of what a quadratic function really is. And these are the first things you should be looking for. The second things you should be looking for are the x-intercepts. So I kind of did that backwards there for you. Sorry about that. I wasn't sure where you guys all were in your studies and your classes, but I've come to find out that most of you had not learned this yet. So here you go. The first lesson as the second one. Hopefully this helps.